Okay, so let's start with a few examples for hydrocarbons. We will complete hydrocarbons now. So let's do some examples based on whatever we have learned in the previous lecture. First one, try this one, then I'll discuss. So in the first one, if I start numbering in this way, this is one possibility. You will have longest chain of 6 carbon atoms. And number of substituents is equal to 1, because then this will become the substituent. So in this manner, if I start numbering, I'll get one substituent, that is this one, and the length of carbon chain is 6. Let's try another way. This could be another manner, that is, I'm starting numbering from this one, 1, 2, and then I go up. Here also I will say that the longest chain is of 6 carbon atoms. Here also the longest chain is of 6 carbon atoms. But how many substituents are here? Let's count that. So if we go ahead with this one, we'll have one substituent as this attached at the second position, and we'll have one substituent as this one attached at the third position. So number of substituents will be equal to 2. So in both the cases, the longest chain is of 6 carbon atoms, but the number of substituents is not the same. Longest chain is of 6 carbon atoms in both the cases, but the number of substituents is not the same. In the first one, if we see, the number of substituents is 1, and in the second one, the number of substituents is equal to 2. So which one should we choose?
So this one.
This one or this one? The second one, right? Okay. So here, So the name will be, at the third position I have this, that is CH3CH2, which is ethyl substituent, and at the second position I have CH3, which is a methyl substituent. Three ethyl, two methyl, six carbon atoms is the chain, so hexane. So this is the correct IUPAC name. Try the second one. Second one is now containing a triple bond. Last time we discussed rules for compounds containing double and triple bonds. So I can combine this. So 7 carbon atoms come in the longest chain. And the longest chain contains the triple bond. At the fifth position, I have one substituent. This one. So the name will be 5-ethyl. Five ethyl 7. So hept. At the second position, you have the triple bond. The second atom has this. So 5-ethyl hept 2-ine. Ine because it's a triple bond. Try the third one. Okay, now the third one. The compound contains both double and triple bonds. So let's number and see what are the positions of the double and triple bonds. If I number from here, this could be one way. If I number it in this way, then the position of double bond is at the fourth carbon, and the position of the triple bond is at the sixth carbon. These will be the positions. If I number from left hand side, if I number from the right hand side, then 1, 2, 3, 4. This will be 5, this will be 6, this will be 7, and this will be 8. If I number from the extreme right hand side, then the position of triple bond will be at the second one, and the position of the double bond will be at the fourth one. Which one should be chosen? So second one, because it's a lower set of locants. 2, 4 is lower than 4, 6. 8 is the longest chain. So oct. Now, if a compound contains both double and triple bonds, then the end of the compound, the name should end as a triple bond. That means the name should end in "-ine", Y-N-E. So the name has to end in "-ine". If it has to end in "-ine", that means before that I'll have to put the other things. So before that I'll have to put the double bond. That means the double bond here is at the fourth position. So fourth one. Okay. This carbon is fourth. So oct 4 in hyphen 2 I. This will be the correct RPC. YNE is I. It's ending as I. Okay. Fourth one. Positions of double bonds, again we have to identify. So if I go from this end, so the positions will be 3, 5, 7. This will be the positions of the double bonds. 3, 5, 7. Let's number in another way and see. If I number from this side, it will be 1, this will be 2. So 2, 4, and 6. This will be the set of locants for the double bond. So I have to choose the lower set of locants. That means the way of numbering should be this. So this is correct and this is wrong. At the second position, I have a methyl group. This indicates it's a methyl. So 2 methyl, 9 carbon atoms. So non hyphen. At the second position, there's double bond. At the fourth position, there's double bond. At the sixth position, there's double bond. So 2, 4, 6. There are 3 double bonds. So try E.
So won't we add in what? Won't we add water?
Is this correct? What I have written?
No.
Why?
नौना होगा.
Yes, correct. So it has to be nona because यहाँ पे T है. Now it is a correct alkane. Okay. Fifth one. 1, 2, 3, 4, 5, 6, 7. In this case, the set of locants will be 2, 4, and 6. 2, 4, 6. If I start numbering from the right hand side, then 1 and so on. So at the first position, I'll have a double bond. So it is 1, then 2, and then here 3. So 1, 3, 5. So obviously this will be correct and this will be wrong because out of 2 and 1, 1 is lower. So 1, 3, 5 is the lower set of locants. So I have to number it from that end. This will be the correct way of numbering. So at the sixth position, I have a methyl. This is methyl. So 6 methyl. Hept. 7. So hept. 1. Because at the first position, I have double bond. Comma 3. 1, 3, 5. Try it. Again, it says there is a T here. I have to write hepta. Now it is correct. So always remember, if you are numbering compounds containing double and triple bonds, then you have to first check that lower set of locants is followed. When you are following the lower set of locants rule for compounds containing double bonds or triple bonds and substituents, then the lower set of locants has to be followed for the double and triple bonds. That means, like in the fifth question, I have taken into consideration the double bonds, the positions of double bonds only. I have not taken into consideration the position of the methyl. Methyl is a substituent, so methyl need not be taken into consideration while checking the lower set of locants rule because the compound contains double bonds. When the compound contains double or triple bonds, you have to follow lower set of locants for the double or triple bonds. So those carbon atoms containing the double bond should get a lower number. Sixth one. One, two, three, 4, 5, and 6. Is this correct?
No, sir. You have to include the triple bond.
So what I have done correctly is containing 6 carbon atoms in the longest chain. Okay. Or let's say I don't start from 1 there, I start 1 from the lower. So 1, 2, 3, 4, 5, 6. Now is it correct? Now the third carbon has a substituent, that is this entire thing is a substituent and this entire thing is a substituent. If I number in this manner.
Sir,
But sir, the main
Is this
chain should
correct?
contain the
sir, हम
triple
लोग right
bond.
से नहीं ले सकते.
Is this correct
Sir,
or
right.
not?
No, so there is one more possibility of having 6 carbon atoms, and it will include the
From the right.
one triple bond.
Okay, that is also another possibility. That is 1, 2, 3, 4, 5, and 6. Correct. That is also another possibility.
The reverse of it, like one from left.
Yeah, yeah. Got it. So is that correct? Or we are just drawing all the, writing all the possibilities, and then we will finally decide. In this manner also we are getting 6 carbon atoms, like someone said. Is this a correct way of numbering this compound?
No, sir.
Okay, even this is wrong. Okay. Then what is the correct way of numbering? How should I number this?
Sir, the straight chain containing all the
Right.
triple bond.
Okay. Correct. So let's go back to that rule which we discussed in the previous lecture last week. Okay. I told you that when you are numbering a hydrocarbon, containing double or triple bonds, then you have to select the longest chain of carbon atoms in such a manner that you get maximum number of double or triple bonds included in the main chain. So if I number in this manner, the way I've done just now, in that case, this triple bond is left out. It is not coming inside the main chain. So it is left out. It is left out. Only this triple bond has been a part of the main chain, this one. Fine. Also, if I number from the bottom and go to 6 carbon atoms, this one, then the problem here is that I'm not able to include this in the main chain. Also, I'm not able to include this in the main chain. So both the triple bonds are left out. They are out of the main chain. The possibility which is containing maximum number of triple bonds or double bonds, if there are double bonds in the main chain, is taken as the correct possibility. Hence, we are left with only one choice here because we have to include the maximum number of triple bonds. So this is the possibility. Only correct way, rather. This will be the only correct way of numbering because in this way I have included all the triple bonds in my main chain.
Sir, but shouldn't this be the wrong way because we aren't taking the longest carbon chain possible and that.
लॉन्गेस्ट कार्बन चेन पॉसिबल के बाद देखो मैंने कंडीशन लिखवाया था लास्ट लेक्चर में, अगर तुम्हारे पास वो अभी नोट्स रेडी है तो उसमें तुम देख
that it
सकते हो
should contain the
कि it
maximum
should
number
be
of double.
selected in such a manner so that it contains the maximum number of double and triple bonds. So if the
सर वो
compound
कंडीशन उससे ज्यादा भारी है, मतलब लाइक
अगर डबल और ट्रिपल बॉन्ड हुआ तो डबल और ट्रिपल बॉन्ड्स को मेन चेन के अंदर इंक्लूड करना पड़ेगा. अगर पॉसिबल नहीं हो रहा है तो अलग बात है, बट यहाँ पे पॉसिबल हो रहा है ना, हम लोग इंक्लूड कर पा रहे हैं सबके सबको, इंक्लूड कर दिया इसके लिए मैंने. So the longest chain is selected in such a manner that you are able to include the maximum number of triple bonds or double bonds in your main chain. That is the condition. So this is the main chain. So at the third position I have ethyl, that is this is ethyl. Ethyl. Then also I have this as a substituent.
Propyl.
This is propyl. And 5, so pent. One comma 4, because at the first I have a triple bond, at the fourth carbon atom, this is the fourth carbon atom, I have another triple bond. So 1 comma 4. There are 2 triple bonds,
Di.
so di-ine, and here it has to be penta because here D is present. This is the correct IUPAC name of this compound. Any doubt in any of these questions?
No,
So
sir.
why did I add A here? Why penta? Because of D. So whenever you see D or T after a number, you add an A. So this rule is followed whenever we have a D or T after a number. So we add A here. This rule is followed when we come across nomenclature of hydrocarbons. These all are hydrocarbons. We have still not come out of hydrocarbons. We are still inside hydrocarbons. All these are hydrocarbons because they contain only carbon and hydrogen atoms. So for naming hydrocarbons containing such D or T after a number, you have to add A after the root word. So penta, hexa, hepta, octa, nona, buta, all these things. Okay. Seventh one. Put a star mark against this. This is a new type. Star mark. Now, in the seventh one, let's try. Is there any other possibility? There is no possibility. Because you have already got the longest chain containing maximum number of double bonds. If somebody says that from 3 I want to come down, then this will be 4. And in that case, this entire thing will be left out. So the longest chain will be 4 carbon atoms in that case. But right now, I can see that the longest chain is of 5 carbon atoms. So we will choose this as the longest chain. Okay. So at the third position, I have a substituent. This is my substituent because it's out of the main chain. This is the substituent because it's out of the main chain. This is the main chain. So this is a very special case. Why? Because the substituent which is out also is connected via double bond, right? This is this double bond CH2. Double bond CH2. When a substituent is of this kind, it is double bond CH2, it is called methylidene. And then pent, because there are 5 carbon atoms. 1, 4. Diene, because there are 2 double bonds in the main chain. And here it has to be penta because D is present after the number. So 3-methylidene penta 1,4-diene. What is methylidene? Methylidene is CH2 double bond, which is lying outside the main chain. See, here I have written, these are some common substituents that you have to know. So here the first one is what we have used just now, methylidene. Right? Double bond CH2. So this one we used just now, this one. So 3-methylidene penta 1,4-diene. If you number from the extreme right hand side, then also the name will be the same, because then also the substituent will lie at the third position. So 1, 2, 3. So now see, then also it is lying at the third position. So it is going to be the third position, whether you number from the left hand side or you number from the right hand side. Any doubt anybody has in the seventh one? Okay. Eighth one. Again, put 2 star marks. Very, very important. Now we'll see why. Okay. Now this has to be first numbered and checked. So 1, 2, 3, 4, 5, 6, 7. First point. Now there are 2 possibilities after 5. After 5, I can do 6, 7 the way I have done, or I can do 6, 7 like this. Irrespective of that, I'm getting 7 as the longest chain of carbon atoms. So whether I go straight or I come down after 5, I'm getting the length of carbon atoms as 7 carbon atoms. That means the length of the chain does not change even if I go on the right hand side. Now what to do? Which way of numbering is correct? Whether I should go down from 5 or I should go on the right hand side of the 5. That's what
Sir,
we
it
have
should
to
be
check.
Right hand side.
double bond, triple bond now. That's why we'll
No,
go
no. See,
straight.
I'll tell you. Now the rule is that it's a very special one, so I've put stars. Let's put 3 stars. Now, first of all, the rule says that select that chain which has the longest chain of carbon atoms containing the maximum number of multiple bonds. That we have done. We have included this multiple bond in our long chain. We have included this multiple bond in our long chain. We have included this multiple bond in our long chain. So we have included 3 multiple bonds in the long chain. That is 7 carbon atoms. Fine. Now, if you go on the right hand side, then also you will be able to include 3 multiple bonds in the long chain. One will be this one will be this one, and one will be this one. So, irrespective of the way, you are able to include 3 multiple bonds in the longest chain. 3 multiple bonds. Which 3? That I've shown just now. Either you are including this, this, and this, or you are including this, this, and this. In either case, you are able to include 3 multiple bonds in the longest chain. So that much is clear. Now, if such a case arises where I am able to include the same number of multiple bonds in both ways of numbering, then I'll have to choose that chain which has the maximum number of double bonds. Okay, I repeat, if I am able to include the same number of multiple bonds in the longest chain, then I'm supposed to choose that chain which has the largest number of double bonds. So the chain which has the largest number of double bonds will be chosen as the main chain, and hence my main chain will be this. So this is the main chain. This is the main chain. Positions of double bond. Positions of double bond.
Sir, we will name opposite now. That will give us
Let's see.
the
That's what I'm saying. Positions of double bonds. That is why I'm writing this. Positions of double bonds in this way will be what? 1. Why? Because this one 1, comma 3. This third carbon atom. So 1, 3. 1, 3, 6. This will be the positions of double bonds in case I number from this end. That is from the left hand side. If I start numbering from the bottom, then what will happen? If I number from the bottom means what?
At third position.
I'll rewrite this so that it's clear to understand.
Sir, we have to. Sir, this one is only right because if we number it from the from down.
Yeah, but I have to show both the ways of numbering. So 1, 2, 3, 4, 5, 6, and 7. In this case, the positions of double bonds are what? 1, that is this one. 4, that is this one. And then 6, that is this one. So we have clearly mentioned the positions of double bonds in this. Now tell me which is correct.
first one.
First one, great, because 3 is lower than 4. So what you do right now, you write down this example properly in your notebook. Explain both the ways of numbering and write down the positions of double bonds. I'm waiting. Please finish it right now. I'm giving 2 minutes. Show both the ways of numbering and write down the positions of double bonds. Write like this. Properly write. Positions of double bonds. Both the ways right now, and then I'll go ahead. Preference is double bond, not triple bond. That is why we have chosen this as the chain. That is why this is outside, right? This thing is outside. This entire thing is outside. It's outside the main chain. Why is it outside the main chain? Because the main chain should contain the maximum number of double bonds. So this is inside the main chain. This is inside the main chain, and this is inside the main chain. The main chain must contain the maximum number of double bonds.
Sir,
Yes. Any doubt?
सर पर ट्रिपल बॉन्ड को तो ज्यादा प्रेफरेंस दिया जाता है
नहीं, डबल बॉन्ड को ज्यादा प्रेफरेंस।
सर अगर ऐसा होता कि आपका जो डबल बॉन्ड से चेन आ रहा है ये है एंड ट्रिपल बॉन्ड के साथ जो चेन आ रहा है वो इससे लॉन्गर है
हाँ, तो फिर ट्रिपल बॉन्ड, यस। The main thing is priority goes to the longest chain containing maximum number of multiple bonds. अब इस केस में दोनों में ही वो 7 आ रहा है longest chain. इस केस में पॉसिबिलिटी नहीं है ना चेन बढ़ाने की। इसके लिए हम लोग उस चेन को चुन रहे हैं which has more double bonds. So, what are the rules? I repeat, in sequence you have to follow. First thing is that select the longest chain containing the maximum number of multiple bonds. That is the first. Second, if the chains are of equal length, then select that chain which has more number of double bonds. बस यही दो चीजें हैं. ये हो गया, लिख के नीचे वाला इरेज कर दूं. डन. ये नीचे वाला पार्ट हो गया, दोनों के दोनों नंबरिंग.
यस सर.
ओके. Now we can write the name. So at the fifth position, I have a substituent. This is a substituent at the fifth position. So 5. Now, what is this substituent called? See, I've written here some substituents. So can I say this is the substituent? C triple bond CH. C triple bond CH. So the substituent is ethynine. 5-ethynyl, hept because 7, 1, 3, 6. There are 3 double bonds, so try in and here, so it's hepta. So this is the correct obvious name of the end compound.
Sir, can you show that table?
Yes, yes.
Yes, sir, please.
So we have to write down the subsequent names, right?
Yeah, right now.
So can you read out the fifth one? Propargyl.
So the fifth one is propargyl. Propargyl or propargyl. Propargyl. Okay. So the eighth one is clear. Anybody wants any explanation in the eighth one?
So the substitutes.
Any doubt in the eighth one? Okay. I think somebody wants an explanation in the sixth one. Now see, in
Sir,
the
no,
sixth
sir,
one, uh-huh.
the sixth substituent, the naming of the sixth substituent, that the table one.
Acha, table. Huh. Pro-2-enyl. Pro-2-enyl.
Sir, but here, if we do by complex naming of substituents, then it should be 2-methadiene.
नहीं ये एक ही साथ है ना लगातार. This is only one simple thing. This is not a complex substituent. ये तो एक ही चेन के अंदर 3 के 3 है ना, बाहर से कोई ब्रांचिंग तो नहीं है.
हाँ sorry.
कॉम्प्लेक्स में ब्रांचिंग होना चाहिए ना, ये तो ब्रांचिंग नहीं है इसमें कोई. So it is like this: 1, 2, 3, straightforward. Okay.
सर आप एक बार के लिए थोड़ा सा ऊपर स्क्रॉल कीजिए ना, कुछ चेक कर.
Scroll up.
हाँ बस सर. ओके सर.
All right. So with this we end our hydrocarbons. So hydrocarbons, I mean nomenclature of hydrocarbons. So nomenclature of hydrocarbons is complete. Okay. Let's start with the next part. So this is the next part. Now don't write down this thing right now. Later you can complete your notes. So just listen, don't write. So now we are entering that part of nomenclature which is no longer restricted to hydrocarbons. Now we have any compound. In general, anything can be asked. So for that, what is the rule we are going to follow? Those rules. So if it is a compound containing multiple bonds as well as some other groups or substituents, or if it is containing only some groups, then there are some rules which are to be followed. In general, again, this is a rule. First rule again is similar to what we have learned earlier. Select the longest possible chain of carbon atoms containing. Now, containing word is important. After the word containing the main or principal functional group and the maximum number of multiple bonds. That means what? Now the longest chain should be selected in such a manner that you have the main functional group as a part of the chain. So like we did in the previous case, that the longest chain should have maximum number of double or triple bonds. Similarly here also, the longest chain should have maximum number of double and triple bonds. But in addition to that, it must have the main or principal functional group. What is principal functional group that we are going to study after some time? Okay. Second step, assign the lowest possible number to the principal functional group. So that means now their discussion is focused on the principal functional group. The entire thing revolves around that. So your first task is to identify the principal functional group within your molecule. So the principal functional group must get the lowest possible number. Use suffix for the principal functional group. That means in the name of the compound, we have to use suffix for the principal functional group, and we have to use prefixes for the other groups. Always remember, fourth one is very important point. Always remember that this only word is important. There's only one principal functional group in a compound. You cannot have more than one main group. There's only one main group inside a compound. That group gets the priority, and hence its corresponding suffix is used. That means whatever is the priority, whichever is the main group, should get the suffix accordingly. That means we have to use suffix only and only for that group which is my main group inside the compound. I'm not supposed to use suffixes for other groups. I'm supposed to use only one suffix for which one? For that group which is my principal functional group. Fifth one is also very important. In any compound throughout organic chemistry, treat these as substituents. So These are few substituents which you have to keep in mind always. So use prefixes for these, because for substituents we always use prefixes. I've written the prefixes for these substituents. Okay, don't write now. Later you can complete your notes. Just understand right now. So I have written the substituents. These are some common substituents which are always going to remain substituents. They will never get any priority. Hence, they are always substituents. And therefore, their corresponding prefixes need to be used. Now, how do we decide which is our principal functional group? For that, we have one order of preference given, or it's called priority series or seniority table. Based on this, we will decide which is our principal functional group. So, the top priority goes to carboxylic acid. Carboxylic acid is represented by this COOH. See, I have written down the representation of every functional group within brackets. So whenever you have a doubt, whenever you're stuck on something, you can check this list or you can check this order. So in this order of priority, we will see which has the highest priority and which has the lowest priority. So in particular compound, while naming a compound, we have to see which functional group gets the top priority or which is the main functional group for us. In order to decide which is the main functional group, we must remember or learn this order of preference. So it will take time, gradually you will learn. So the top is carboxylic acid. This is the first one in the priority series. That means it has the highest priority and followed by other things one by one. So this is a decreasing order or descending order of priorities. Decreasing order, that means from highest to lowest. So highest priority goes to carboxylic acid, followed by sulfonic acid, followed by acid anhydride, and so on and so on. In this way, you will have the priority series. So this is a decreasing order of priority series, which you have to remember, right? So at the last, we have amine. That means that has the least priority out of all these. Highest priority is of carboxylic acid and least priority is given to amine out of all these. In between these two, we have the other things. Once we solve a few questions, we will be able to understand as to how to proceed with priorities. Okay. So based on the priority, you have to decide what is going to be used. As I said, if your functional group is priority, then you have to use suffix for that. And whatever is not the priority, for that you will have to use a prefix. Right? So within the same compound, you will have only one suffix, but you may have multiple prefixes. So only one suffix is used because only one functional group gets the priority within a single compound. So let's come to a few examples. Example number one. So example number one, if we check, let's see what we have to do. In the first example, let's identify if there is anything which carries the priority. See, in this, you have one oxygen atom. So definitely this is not a hydrocarbon. Whenever it is not a hydrocarbon, you will have to follow the rules which are described just above. Oxygen is present, so this is not a hydrocarbon. And now I go with the rules. One by one, I'll see which rule is applicable. Can I say that I am clearly able to see OCH3 present here? So OCH3 is present in this compound. OCH3 is present in this compound. If you go to the set of rules, you will find that there the fifth rule has clearly mentioned that OCH3 is always a substituent, and hence OCH3 is going to be used as a prefix. So OCH3 is what? OCH3 here is methoxy. That means whenever you see any of these, so the fifth is extremely important. Many people go wrong in the fifth points. So in the fifth point, please remember this, that these are a handful of substituents which will always remain substituents, by which I mean that they will never get priority in any compound. So If I come across any of these, immediately I should know that it is acting as my substituent, and so I have to use its corresponding prefix. OCH3 is called methoxy given below, so I'm going to say that yes, OCH3 is methoxy. Fine, let's go ahead. Once we have identified that OCH3 is present in a compound, we can say that focus on the remaining portion of the compound. The remaining portion of the compound is simply hydrocarbons, right? There is nothing else. If I leave OCH3 apart, I don't see any other functional group present in the remaining molecule. I just see carbon and hydrogen atoms in the remaining portion, which clearly makes me understand that I'm supposed to follow the normal system of nomenclature that we used to follow for hydrocarbons. So here, there is no functional group apart from OCH3, which will let me decide anything else. So 1, 2, 3. This is the normal way of numbering because there is no other principal functional group. If I ask you, which is the principal functional group? If I ask you, which is the principal functional group in this molecule, you will say that there is no principal functional group in this molecule. Why? Because OCH3 is never a principal functional group. It is always a substituent. And apart from that, whatever else is remaining also does not contain anything of any functional groups. By which I mean that out of these 12 things that I have written, none of them is present in this molecule. And hence there is no functional group which is getting the priority. That means there is no priority at all in this compound. Okay. So let's see now what we have to do. Having understood that there is no group taking the priority, it is easier for us to name this because then we don't have to consider any priority series. If there is no group present which can get the priority, then what is the point of looking at priority series? That means for the first question or the first example here, we need not look at the priority series. All right. So, since there is no need of any priority series in this example, I will name this compound normally. So this becomes my longest chain of carbon atoms, 1, 2, 3. At the second position, I have this as a substituent, and also I have this as a substituent. So I can say the name will be 2-methoxy. Two-methoxy, 2-methyl. Because there are two substituents, one is methoxy and one is methyl. So 2-methoxy, 2-methyl. Longest chain is of 3 carbon atoms, all are single bonds, so propane. 3 carbon atoms, right? So pro. And there is no double bond, no triple bond. So ANE. So this is the correct obvious name of the first compound. Now, O comes before Y. That is why I wrote methoxy before methyl. While writing the final name, alphabetical order has to be followed. So O comes before Y, and so it is 2-methoxy and then 2-methyl. Okay. Let's understand the next part. Second one. Let's see which all groups are present here. Again, we see that we have NO2 present, and as per point number 5, NO2 is always going to act as a substituent. Apart from that, let's see what other thing is present. We see COOH, right? COOH, carboxylic acid. So carboxylic acid, COOH. That means in this compound we have our principal functional group as COOH. The principal functional group is obtained as COOH. If something is a principal functional group, then we have to use its suffix. Suffix is what? Here the suffix is oic acid. Whatever is the principal functional group should get its suffix. So I have to start numbering now in such a manner so that I get the longest possible chain of carbon atoms. So 1, 2, 3, 4, and 5. So I can say 3 nitro because NO2 is always called nitro. It's a substituent. So 3 nitro, 5 that means pent. So pentanoic acid. Why did I do this? Because COOH is the principal functional group and the COOH has its suffix as oic acid. Whatever is the principal functional group must get suffix. So suffix is oic acid here. So it is pentanoic acid for the second example. So 3-nitropentanoic acid. There is no space between nitro and pentanoic. There is no space. But here there is space. After pentanoic, there is a space and then we write acid. Okay. So second one is done. 3-nitropentanoic acid. Coming to the third one. Coming to the third one. Now, what is the group that's present? Can I say it is C double bond O? C double bond O. So what is C double bond O? Let's check that.
Ketone.
C double bond O is this one, ninth one, right? So this is ketone. Now only one functional group is present. So if only one functional group is present, that means that gets the priority. So for the C double bond O, ninth one, I'm going to use a suffix which is ONE, on. Why am I using suffix? Because it is the only and only functional group present in my compound. So that itself gets the priority. If there is only one functional group in the compound, that itself gets the priority. Because there is only one. So ONE, on is the suffix. Now, that way if you see while numbering, we will get this 1, 2, 3. And the name should be propan to on. But there is one convention that's followed for this third one and also for the fourth one. That is, for these two compounds, that is for the third one and for the fourth one, we do not mention the position of the ketonic carbon. It's by default understood that it is 2 and hence we just write propanoone. So don't write propan 2-one. Similarly for the fourth one, if I start numbering,
Any reason behind it?
I'll tell you the reason. So if I start numbering, then it will be butan 2-one. But we don't write butan 2-one, we are supposed to write butanone. So this is what is written. Don't write butan 2-one. Don't write propan 2-one. So for these two ketones, we do not mention the position of the ketonic carbon, only for these two. Now why? Because there is no other possibility for a position of the ketonic carbon. Whether you go from left to right or you go from right to left, always you are going to have ketone as at the second position. So you don't mention the position of ketone. Similarly, if I come to the fourth one, whether I go from left to right or I go from right to left, in these two cases, I mean whether I go from left to right or I go from right to left, I will be left with only one option, that is to position it as the second carbon, because If I go from right to left, then the ketonic carbon is at the third one. If I go from left to right, the ketonic carbon is at the second carbon. But out of 2 and 3, 2 is lower, so it's by default understood that that itself is going to be the name, which means that there is no other possibility for the position of the ketonic carbon. So you write only butanone and not butan-2-one. Similarly, for the fourth one, if I write like this, I can write the fourth compound like this as well. Again, it's the same thing. The ketonic carbon is at the second one. So I do not write butan-2-one, I just write butanone. So for the third and fourth ketones, we have to remember that we are not supposed to mention the positions of the ketonic carbon. Only for third and fourth. That is only for propanone and butanone. We do not write the position of the ketonic carbon. We just write propanone and we just write butanone. We don't mention whether it is 2 because 2 is by default present. So it's not mentioned. So remember these two. Okay. Coming to the fifth one, let's try to identify which all groups are present here. Can I say that this group in the fifth one is COO and then here CH3? This is how I can decode it. So can I say it is COO?
Easter.
So COO and then again that O is connected to carbon. What is that? Let's see. Let's go up, let's scroll up and then check. So see, I've got this as an ester, that is CO and then O. COO. So it's an ester. Since there is only one functional group present, that's ester is the only thing which is present, then I have to use that suffix. So this is the third one, ester, COOR. What is the suffix for an ester? The suffix for an ester is this, alkyl alkanoate. Alkyl alkanoate. Let's understand what is that. Alkyl alkanoate. So COO is ester. Since apart from ester nothing else is present, that means that becomes my principal functional group. Since that has become my principal functional group, I will use suffix for that. So suffix is alkyl alkanoate. Alkanoate rather. So what is that? That we have to see now. So remember, if it is ester which is your principal functional group, the numbering has to start from the carbon which is COO. So 1, 2, 3. This is how you have to number. This is how you have to number. So 1, 2, 3. So can I say 1, 2, 3 is propanoate? So it is propanoate, alkanoate. So the suffix is propanoate here. Now, what about this one? So this portion is present after oxygen. Whatever is present after oxygen is written before, which is methyl. So we will write it as methyl propanoate. So for an ester, the numbering has to start from this carbon. Okay, the carbon which is COO. From that carbon, the numbering has to start. That is the first thing. The second thing is that whatever is written after that oxygen atom, that becomes as alkyl, and that is written before. Try the sixth one. Okay, let's try the sixth one. Again, it's COO. So COO, so ester. This is C. So C double bond O and then O. So it's ester. right? So 1, as I said, the numbering has to start from that carbon which is CO. So 1 and then 2. 1 and then 2. So for 1 and 2, it means there are 2 carbon atoms in the main chain. So I have to say it, no it, right? It, no it. Now, before that, I have to write whatever is present after oxygen. After oxygen, what is present? After oxygen, this is present. This thing. Can I say this is again 1, 2, 2 carbon atoms? Can I say it is ethyl? So this entire thing can be written as this. Right? So this entire thing can be written as this. So this is 1 and this is 2. And so I wrote ethanoate. After oxygen, it is CH2, CH3. That is ethyl. So I wrote ethyl before. So the full name is ethyl ethanoate. Any doubt anybody has in this one? Let's try another example. This is another example. Now we see there are 2 groups present. One is COH and one is OH. In the priority series, I told you that more the priority, it will lie on the left hand side of the series. So if I start looking at the series, I will see that COH is there as the first one. So it is the first functional group, and that is where it gets the top priority. So that has to be 1. Then 2, 3, 4, 5. Longest chain, right? So I cannot say 1, 2, and then 3. This will be wrong. Because I have to select the longest chain in such a manner so that I am able to include the principal functional group. I have included that already. It is 1. I have taken it as 1, that is COH. And then I went up, that is at the second carbon. And then I went on the right hand side, that is 3, 4, and 5. So, can I say that now the length of chain is of 5 carbon atoms and the principal functional group is COH. For the principal functional group, what will I use? I will use suffix. So 1, 2, 3, 4, 5, and so I can write this as the ending will be like this. The name will end in this manner. 1, 2, 3, 4, 5. So pentanoic acid. Why oic acid? Because COOH has got the priority, and so I have used its suffix. That means for the other things, I'll have to use the prefix OH. That means for OH, I have to use the prefix, right? What is the prefix for OH?
Good.
So OH, 10th one. The prefix for OH is hydroxy. So at the 4th position, I have hydroxy. So 4 hydroxy, 2 methyl. Even Even this is there, right, as a substituent. So 2 at the second carbon I have methyl. So 2 methyl, 4 hydroxy, 2 methyl pentanoic acid. So this is the correct IUPAC name of the 7th compound. Last one.
So hydroxy came before due to alphabetical order.
Yeah, alphabetical order ना, H तो M के पहले ही आता है ना.
नहीं आई थॉट कि वो फंक्शनल ग्रुप था अभी उसका
नहीं तुम्हारे सारे सब्स्टिट्यूएंट्स बन गए ना अभी. तुम्हारा जो फंक्शनल ग्रुप है वो तो सिर्फ ये वाला है, ओइक एसिड वाला पार्ट है. बाकी सब सब्स्टिट्यूएंट्स बन गए ना. एक ही कंपाउंड में सिर्फ एक ही चीज को प्रायोरिटी मिलती है, बाकी सब बन जाते हैं सब्स्टिट्यूएंट्स. So H comes before M, and so I wrote hydroxy before methyl. So CHO is present. CHO is the principal functional group in this compound. एक ही है ना, उसके अलावा और कोई तो है नहीं. तो एक ही है तो एक ही को मिलेगा प्रायोरिटी. 1 2 3 4. So but second position पे डबल बॉन्ड है. So but 2 in, and then the suffix Al is the suffix. Al. देखो टेबल के अंदर दिखा देता हूं. So for the 8th one, Al is the suffix. Due to enal. Some books also write it like this. Right? It's by default understood. I told you last time that 1 is there.
Al is the substituent, right?
Al is a नहीं
suffix. Al is
suffix है, principal functional group है.
हाँ सर.
Any doubt? Anybody has?
सर इसमें हम लोग प्रीफिक्स नहीं लिखेंगे क्या?
प्रीफिक्स कोई है ही नहीं ना, किसके लिए लिखोगे प्रीफिक्स?
जो दो होंगे तभी एक प्रीफिक्स आएगा मतलब.
हाँ, 2 या 2 से ज्यादा आएंगे तो ऑब्वियसली एक के लिए सफिक्स और बाकी सब के लिए प्रीफिक्स. यहाँ पे एक ही ग्रुप है ना, एक ही ग्रुप है तो सिर्फ सफिक्स आएगा.
मतलब सफिक्स वही होगा जिसको ज्यादा प्रायोरिटी मिलेगी.
यस, प्रायोरिटी जिसको ज्यादा उसका सफिक्स, बाकी सबका प्रीफिक्स. चलो वन एग्जांपल. I have two groups. One is C double bond O, it is a ketone, and one is COCl. प्रायोरिटी देखते हैं कीटोन और COCl में किसकी ज्यादा प्रायोरिटी है. लेट्स चेक दैट फर्स्ट. हाँ, कीटोन यहाँ है और COCl इधर है, तो प्रायोरिटी किसकी ज्यादा हुई? एसिड क्लोराइड की ज्यादा हुई, यानी COCl की ज्यादा प्रायोरिटी हुई. राइट. So out of ketone and acid chloride, the priority will go to acid chloride. क्योंकि ये बाद में आ रहा है, डिक्रीजिंग ऑर्डर में है ना. सो एसिड क्लोराइड की प्रायोरिटी ज्यादा है कीटोन से यहाँ पे.
सर ये पूरा हमें लर्न करना पड़ेगा.
यस, दिस हैज टू बी लर्न्ड, दिस सीरीज. इसको लिख के प्रैक्टिस करना पड़ेगा. दिस विल टेक टाइम, सो लर्न दिस. लिख के करो इसको प्रैक्टिस. सो एसिड क्लोराइड एंड कीटोन में से ज्यादा किसको प्रेफरेंस है? एसिड क्लोराइड को है, इट इज द फोर्थ वन। प्रायोरिटी उसको है तो हम लोग उसका सफिक्स लेंगे, सो ओइल क्लोराइड एंड CO दैट इज कीटोन का प्रीफिक्स लेंगे, दैट इज ऑक्सो। So 1, 2, so 3 oxo. Why oxo? Because कीटोन का प्रीफिक्स लिया है। क्यों? क्योंकि उसको प्रायोरिटी नहीं है, यहाँ पे प्रायोरिटी COCl की है। पेंटा नोएल क्लोराइड। This is the correct IUPAC name of the 9th example. COCl का सफिक्स लिया है, that is oil chloride, ये सफिक्स लिया है, so pentanoyl chloride. Okay, now all of you try to solve this one. This is the last question and then we will stop. Yeah, tell me, how many different functional groups can you see out of those 12? I mean, out of the ones which are present in your priority. Priority series में से कितने यहाँ पे दिख रहे हैं?
2.
Yeah, 2. Correct. Which 2?
कीटोन नहीं,
COOH
एक
and
कार्बोक्सिलिक एसिड दिख रहा है और एक CO।
One is COOH, that is carboxylic acid, and one is CONH2. That CONH2 is called acid amide. तो कार्बोक्सिलिक एसिड और एसिड अमाइड में से
कार्बोक्सिलिक का सबसे ज्यादा
yes,
हाई है,
कार्बोक्सिलिक एसिड का प्रायोरिटी सबसे ज्यादा है,
तो उसका ओइक एसिड हो जाएगा और उसका जो भी है
तो उसका सफिक्स लेंगे यानी ओइक एसिड, दिस वन। और फिफ्थ वाला देखो CONH2, उसका प्रीफिक्स लेंगे, दैट इज कार्बामोइल, कार्बामोइल, दैट इज द प्रीफिक्स फॉर CONH2. CONH2 is called acid amide, यहाँ पे देखो लिखा है एसिड अमाइड। उसकी प्रायोरिटी कम है, किससे? कार्बोक्सिलिक एसिड से, ये तो सबसे ज्यादा प्रायोरिटी है। तो जिसकी प्रायोरिटी ज्यादा उसके लिए सफिक्स, जिसका प्रायोरिटी कम उसके लिए प्रीफिक्स। So 1. See, I cannot start numbering 1 here, huh? क्योंकि यहाँ पे प्रायोरिटी उसको नहीं है, तो ये गलत होगा अगर किसने ये किया तो। यहाँ पे 1 होगा। This will be the correct way of numbering. So name will be 2-bromo. 4 पे जो प्रीफिक्स है CONH2 का वो लगाएंगे। Oil and hex 6, so hexanoic. Okay. So रिवाइज ऑल दीज थिंग्स, कंप्लीट योर नोट्स. नोट्स में ये सारे एग्जांपल्स और जो प्रायोरिटी सीरीज है, जो रूल्स है, वो सब लिख लो. पूरा नोट्स कंप्लीट करो. थियरी यानी यहाँ पे जो मैं अभी भेज दूंगा ये. कंप्लीट योर नोट्स एंड देन कम फॉर द नेक्स्ट लेक्चर.
सर पार्ट टेस्ट में कितना आएगा?
टेस्ट का डेट बताओ मुझे, मैं बता देता हूँ फिर.
सर नेक्स्ट संडे.
ओके, तो आज तक जितना पढ़ा है उतना तक आएगा.
ओके सर.
मतलब तुमको प्रायोरिटी सीरीज लर्न करना पड़ेगा. सो देयर इज नो अदर वे. तो आज तक जितना पढ़ा है उतना आएगा. ओके, नाउ लिसन. Since we have done today priority series and already we have completed almost 60% of the chapter, I want you people to start solving questions from Himanshu Pandey. हिमांशु पांडे का पीडीएफ बिनानी सर ने डाला था ग्रुप पे, तो सॉल्व करना चालू कर दो. वहां से लेवल 1 से चालू करो. लेवल 1 के क्वेश्चंस कर लो. मैं क्यों बोल रहा हूं? ताकि पार्ट टेस्ट के पहले तुम्हारा हो जाएगा थोड़ा बहुत प्रैक्टिस. So you can start solving questions from Himanshu Pandey level 1.
सर आप एक कोई ऐसा असाइनमेंट दे सकते हैं जो सिर्फ प्रायोरिटी सीरीज पर हो?
उसमें है ना, वही तो बोल रहा हूँ, लेवल 1 के क्वेश्चंस उसका तुम निकालोगे ना. पहले ये है कि सबके पास है कि नहीं है वो पहले बताओ. हिमांशु पांडे सबके पास होना चाहिए वो.
सर पीडीएफ तो
ग्रुप पे पीडीएफ भेजा.
हाँ, ग्रुप पे पीडीएफ सर ने भेजा था ना, तो आई थिंक रहेगा फिर. एक बार सर ने भेजा था वो. So you have to follow that. उसमें लेवल 1 कर लो बस. ओके, लेवल 1 कर लो. यू कैन सॉल्व. बस ये ध्यान रहे कि जब क्वेश्चन सॉल्व कर रहे हो तो ऐसे क्वेश्चंस मत करना, ये वाले जो ऐसे टाइप के क्वेश्चन दिखेंगे बाय चांस तुमको, ऐसे रिंग्स बने हुए साइक्लिक स्ट्रक्चर्स. ओके, ऐसे टाइप की चीजें अगर दिख गई तो उनको सॉल्व मत करना, क्योंकि वो अभी तक हम लोगों ने नहीं किया है. ऐसे टाइप के क्वेश्चंस अगर दिख गए, ओके, ऐसे टाइप का क्वेश्चन दिख गया कुछ भी ना, यानी साइक्लिक स्ट्रक्चर हो गया या रिंग दिख गया, तो उनको सॉल्व नहीं करना है हिमांशु पांडे से. उनको छोड़ के जो हम लोगों ने किए हैं अभी तक, यानी साइक्लिक छोड़ के वो करने हैं. तो अगर इनमें से कुछ भी दिखा साइक्लिक वाला पार्ट, वो छोड़ दो, बिकॉज साइक्लिक पार्ट्स वी हैव नॉट येट डन. वी विल डू लेटर इन द नेक्स्ट लेक्चर. विल ट्राई दैट. तो अभी साइक्लिक वाला मत करो. साइक्लिक छोड़ के बाकी जितना हुआ है वो खत्म कर लो. लेवल 1 करो पहले. लेवल 1 वहां पे लेवल 1 से चालू करो. ठीक है, सो डोंट डू दिस थिंग्स, साइक्लिक वाले पोर्शंस. Okay, thank you.